I'm going to guess that you used a HMI today, maybe without even realizing it. It could be an ATM, the touchscreen in your car, or even the thermostat in your home. HMIs are everywhere. In industrial settings, they're used heavily in automation. They allow operators to control machinery, operate production lines, and ensure the safety of an entire factory. HMIs are everywhere. So what actually makes something a HMI, and how does it even talk to the machines underneath? HMI stands for Human Machine Interface. Taken literally, a HMI is any interface, physical or digital, that allows a human to interact with a machine. And you'll literally see them everywhere, both in and outside of your home. A perfect example is an ATM, which uses a mix of physical buttons and a digital display to allow you to interact with the banking machine behind the HMI. And in factories, HMIs could show pressure, temperature, or machine states, so operators can take the correct action fast. So now we know what a HMI is, let's explain how all of this connects. So the HMI itself doesn't drive the motors or valves directly, it talks to a PLC, a programmable logic controller. It's that which controls the motors, the actuators, and then feeds back that information from the PLC back to the HMI. So you can think of the HMI purely as the interface that the human interacts with, and then that information goes to the PLC, which goes to the machine and then relays the information back. This communication runs on industrial standards, and some common ones include Modbus, Ethernet IP, and Profibus. The choice depends on hardware, the vendor, and performance needs. And the protocol support is a big part of the kind of equipment that you'd use for a specific project. And in older plants, you'll still actually find purely physical HMIs. Banks of blinking lights, segmented displays, and selector switches. They actually worked really well. So well, in fact, that you'll often see physical HMIs still in use today. Modern systems, however, are relying more heavily on digital displays, mainly because it can lower production costs and make the display more flexible. If a new pump, for example, gets installed, you just change the UI on the digital HMI rather than having to reinstall a physical HMI or drill holes in an existing physical display. And you may be thinking, aren't these just computers? And you'd be sort of right, but there are key differences. The first is that HMIs are purpose-built. They're built using vendor-specific tools and designed for typically a single purpose. Three of the big players are Siemens WinCC, Rockwell's Factory Talk, and Schneider's EcoStructure. Real-time feedback. In industry, we design for responsiveness. PLC scan times are often under 10 to 50 milliseconds, and HMI update rates are typically sub-second. If a pressure spikes, the operator needs to see it immediately rather than after a page refresh. The next is reliability and safety. These systems are designed to run continuously with almost no downtime. You'll find examples of hardened Windows, embedded Linux, and hardened runtimes locked down to specific usages, because we can't be seeing a blue screen in a live production line. The next is that they need to be rugged by design. In public spaces, we have to contend with harsh environments such as dust, vibration, or water. You'll see metal enclosings, protective coatings, and IP65 ratings or higher. And a quick note on the architecture for the engineers in the room. HMIs often sit along something called a SCADA, a supervisory control and data acquisition system. That can be a bit of a mouthful, but basically it provides site-wide visibility. While a HMI can allow engineers to control a single machine, a SCADA system can allow engineers to have complete visibility over potentially an entire factory or even multiple sites. It collects data from dozens, sometimes hundreds of PLCs, things like pressure, temperature, system states, collating all of that information into a single location. Operators and engineers can trend that data, set alarms, or even make adjustments remotely. In a way, the HMI is the workstation on the factory floor, and the SCADA is the watch station controlling the entire network. Testing matters, and especially at scale. When you have a single HMI with maybe 10 screens, manual testing is feasible in about an hour. But when you have large HMIs potentially interconnected with a SCADA system with maybe 200 plus screens, then manual testing becomes completely unfeasible. And that's why automated testing is becoming standard practice. And also another reason why it's far more cost effective to switch to digital only displays is because it introduces the possibility of this automated testing. Tools like AskUI can automate operator workflows, so before every major release, you can run a test suite across hundreds of screens, guaranteeing the safety of your system every single time. This has real value when you launch the same HMI across multiple lines or even facilities. You can automate once, rerun everywhere, and keep a regression suite that you can trust. So whether it's heating seats in a car, dispensing cash at an ATM, or keeping a production line in spec, HMIs are the human side of automation. Behind every HMI is a PLC, a protocol, and a set of choices that trade cost, speed, and safety. Get those choices right and your plant runs smoothly. Get them wrong and you're gonna feel it.